Yep.
Yep.
If anything, our group will be known for its very nice slide presentations.
Yeah.
I think Caron dropped. Okay, he's back. I think we should begin before Raquel arrives. She said she can catch up as we go.
Okay. Okay, so I got a little bit carried away with the slide, so it's a bit long. But I also tried to be as thorough and also retain like the formal aspects of the theory. So hopefully it will be also useful in terms of understanding the formalism, which is probably the hardest part to actually understand. But so I'll actually start with some more like experimental context of the area of research, scientific research in consciousness, and like showing how the problem of consciousness appears concretely, like in the clinic, and what kind of experiments are done. And then I'll use that to kind of like motivate how this integrated information appears in which kind of context. So, and then of course, I'll go through like the axioms and the axioms of experience and the postulates of the physical substrate, and then arrive at its main identity, which postulates an identity between a certain structure of cause-effect power and phenomenology. And then I have like some discussion points if we get there. Okay, so there's, I guess, this nice definition by yes, maybe some context before the integrated information theory. It was kind of like developed in 2004 by Giulio Tononi, and it was actually developed a little bit before with Gerald Edelman, which was like the guy who discovered the antibodies, but it comes in. It's probably one of the main candidates for a theory of consciousness today, and it's really influential, and it's also distinctive because it's different from like more cognitive theories like the global workspace and other ones. So it's quite original in many aspects. But okay, so I'll start with this definition by Tononi, which I think is really useful because it doesn't tells you what consciousness is. It just shows you where it happens and where it doesn't. So it's kind of like a negative definition. So everybody knows what consciousness is. It is that what vanishes every night when we fall into dreamless sleep and reappears when we wake up or when we dream. So this is what we mean when we talk about consciousness. It's the world of experience and that vanishes during dreamless sleep. So it's not self-consciousness is not like some more particular form of consciousness, but just subjective experience in general. And it's interesting because it's something that happens every night. So it's there's also this another quote from Giulio, which says that it's the fact that we sleep and wake up every day makes out like a routine experiment that we have with consciousness, that we can actually experience it fading and coming back, and he calls it like the greatest experiment you could ever do. And that's interesting because by this definition, like you have a certain state in which it occurs and a certain state in which it vanishes. That's basically enough to do experiments in science, because you can just contrast these two states without knowing what they are. You know when they occur, so you can basically look at the brain and contrast the brain in these two states, and basically the whole last like decades of research has been contrasting in smart ways the brain while it is unconscious and when it is conscious. So so first, the way that the problem of consciousness appears in the clinic is really like impressive, because you have like this clinical problem of diagnosing brain injured patients where you don't know whether they are conscious. But from start, consciousness is normally easily assessed in wakefulness. It's kind of like behaviorally marked by general state of arousal, like ability to communicate and to interact with the environment. Just a second. Tá. Não precisa, não. Não. Tá bom. Yeah, sorry. And so in wakefulness, we have no problem in telling if someone is conscious, right? You have lots of behavioral signs in which you can basically say, because the person can tell you, and you have all sorts of behaviors, and the fact that the person is connected with the world, both sensorially and in terms of motor output, allows you for that. But you have altered states of that you lose this connection between behavior and consciousness. You have the main case is dreaming, in which you're mostly disconnected from the world, like you experience is still there. You have a whole new world of subjective experiences, but sensory input is basically more or less blocked, and you also have no like motor outputs. So the same happens in ketamine anesthesia. And then you have like more bizarre cases like sleep paralysis, in which you do receive like sensory input, but you lose any ability to move. That often happens like some people when they have just woken up. And also you have like this terrible case of locked-in syndrome, in which the patient is conscient, but he has no like capacity to like control his body. And then you have maybe the contrast case in which you get some like weird motor behaviors and sensory input, like sleepwalking, in which you're presumably unconscious. So, and then also like the philosophical case of the phenomenon of zombie, in which you have like behaviors without consciousness at all. So this led to this nice concept of islands of awareness, in which it is actually like feasible, not only like conceivable, that you could get in principle like full consciousness with that is completely disconnected to the environment. So in the cases of like if you could maintain like the brain in some like in the right physiological conditions, it could, outside of a body, you could presumably it would still be conscious at least for some time, but it would be completely like isolated from the environment. So this dissociation basically sets up the kind of problem you have to diagnosticate consciousness in disorders. So in brain injury patients, you basically have like a vegetative state in which the person is like awake, it sleeps and it's awake, but it has like no signs of like being able to like interact with the environment. So people just presume they're unconscious, but you have basically no way to assess it apart from this. So if you can demonstrate clinically if these patients can show any of these behaviors, like being able to like verbally communicate in some sense, then you know it's conscious. Otherwise, you just, I mean, in the clinic, you normally just presume the person is unconscious. But it is known there are lots of like false negatives in the diagnosis of vegetative state. So it's kind of like a big problem. So, so this motivates the kind of search for like neuronal markers of consciousness. And I'll just now discuss some an approach that I've worked with during my master's, and it's the possibility of kind of like actually developing some index that is independent of both the sensory input and behavior, right? So this is like how your brain reacts when you're like when you do like a small local perturbation in your cortex while you're awake. This is like the EEG response to this perturbation. Let me see if I can show you the video. I don't think I can play this.
It seemed like the cursor became
Sometimes you need to, yeah. Yeah, go into presentation mode in order for the embedded videos and audios to work.
Are you seeing the video?
Yeah.
Yep.
Yeah, so this is like your brain reacting to this perturbation while during awake. So you can see it's like a really nice and complex response that's both spatially and temporally complex. This is awake. And then when you fall asleep, normally like in deep sleep, non-REM sleep, which you probably are not dreaming also. That's what happens with the response. So this the same area. The response just collapses into like this really stereotypical and simple slow response. Mm-hmm. So it's not that your brain is inactive, it's still reacting. It's just that it lost all its spatial diversity and temporal like complexity. You can look at the responses we must. So, and this is interesting because you're like directly probing the cortex and its causal reactivity without actually needing to like use any sensory or motor like pathways. You just bypass it and directly like strike it inside and see it. So this led to the development that it was in fact inspired by IIT, so by the principles, but it was actually like this empirical version of of an index of consciousness different from phi. So so this was my supervisor in the masters. He actually basically tried to compress the signal using kind of like a compression algorithm. And so you basically binarize this spatial temporal response into like a matrix and try to zip this response. And if the response is complex, you get a high value of compression. Otherwise, you get no, the opposite, right? A low compression, you get a high value of an impulsive complexity. Otherwise, you get low values if it's highly compressible. So if this matrix is very simple, which is the case in like sleep, you get low values. And what's really cool is that it's not specific to like wake and deep sleep. That's also the case for like all sorts of anesthesias, like these three kinds of anesthesias. And this complexity value actually raises during REM sleep, while you dream, and also during ketamine, in which is an anesthesia in which you're still conscious, but you cannot like move at all. So it's not like a marker of responsiveness. It's surprisingly specific to consciousness. And also in cases of like the person has a stroke or locked in syndrome cases, you still get like high values of PCI. So I mean, so this actually, then we tested in like patients in which you didn't know, like, for example, so you have like a minimally conscious state in which you had some signal and you get like values of PCI that were like above the threshold. And otherwise in vegetative states, which is the case you don't know, most patients were below, but you got like these high PCI cases in which you just presume the person is unconscious, but it had like a complexity that's compatible with consciousness. So, and this is actually correlated with the outcome of the patient. So that's that. So that's like how like the problem was kind of like, we had some progress with indexing consciousness. And now I'll just try to briefly discuss another context in which like consciousness research appears, is in the search for the neurocorrelates of consciousness. So it has been like defined by Christoph Koch and Francis Crick as the set of neuronal regions in which that's minimally sufficient to engender consciousness. So what you did is similar to what I was telling you, like contrasting brain regions. So in this first case, you're just like looking for like specific correlates of like a particular content of consciousness. So in this case, you would just like show a face that's hard to see. So you just flash this face, and sometimes you see it and sometimes you don't. So the person will tell you, and then you like separate the trials between when you see it and when you don't see it, and then you just like look at the difference. And presumably like this difference in activation is correlated with consciousness. So it's considered a neurocorrelate of consciousness. And the same is done in difference between global states of consciousness and unconsciousness, like contrasting wake and sleep. And so just interrupt me like if I'm going too slow, or if, I don't know, you have questions. So I'll just also show you like a kind of like state-of-art recent experiment using on the neurocorrelates of consciousness, in which you have what's called a within state paradigm. So here you contrast like wake with sleep, right? So the problem with this is that you might get differences which are not due exactly to consciousness, but are specific to like some background conditions that allow for example, wakefulness. So they're not like, and here you have a paradigm in which you probe consciousness in the same brain state, like non-REM sleep. So the way that works is like the person sleeps and you wake up like the person like multiple times during the night, like 20 times, and just ask like, were you dreaming? Were you dreaming? Were you dreaming? And then the person like wake up, tell you if he was there or not. And then you look at the brain activity in the previous like 2 minutes of EEG, and then you contrast that. And what you see is something really interesting, is that you basically have this posterior hot zone in which you get, so this is slow activations, this 1 to 4 hertz, which are basically like the hallmark of deep sleep and of unconsciousness. You get a reduction of that during dreaming, and you get an increase in high frequency activity. So you get some form of like desynchronized complex activation in the back that correlates really well with the presence of dreaming during non-REM sleep. And then another thing that I think is really cool is that if you parse the content of the dream between dreams that are like more like perceptual from those that are more like conceptual, like pure thoughts versus like purely perceptual dreams, you get like this nice like gradient from front to back, in which more frontal regions are related to dreams about thinking, and more posterior to dreams about perception. So I mean, this is basically like the state of art of the current experience, then searching for the neural correlates of consciousness. Yeah. So, but of course, this paradigm is it has its limitations. I mean, it's a really empirical, data-driven approach. So you're always dealing with neural correlates, right? But you could also always ask, what about like, could consciousness in other kinds of substrates, right? So you have always the question about machines and aliens and stuff that don't necessarily have neurons at all. And so and it's also like a descriptive account of differences between basically healthy adult brains, in which you already know that consciousness is there, but so you have no way to extrapolate to like non-neural substrates or like and nor explain why exactly those regions are relevant for consciousness. Like why so normally we have the cortex as the neural correlate of consciousness, but why not the cerebellum, which is like this region in the back of the brain in which it receives like sensory input, it processes, like it controls behavior, it's like it has as much neurons as the cortex. So like, but if you cut it out, you basically live like the same person, like you're still conscious, fully conscious. You just like kind of shake a little bit with your hands. You can't play piano, but you can basically remove this thing. So it's not clear from this kind of like approach why one sort of architecture is relevant and the other one not. So this leads us to like you need some kind of like theoretical approach that can like deal with the general problem of what kind of physical substrate is able to engender consciousness. So this is more or less where IIT sets in and tries to like deal with this challenge in which you cannot derive just by looking at the brain and its mechanism. You cannot like deduce looking at the brain like why and how exactly something is conscious and what kind of content then it would be implemented. It's hard to think how would that happen. So what IIT does is try to do like the opposite move, actually look first at consciousness and then try to infer its physical mechanism. So IIT has this general strategy which is really particular to it. There's no other like theory that I know does that, and it's kind of like weird for like a neuroscientist to actually propose something like that. I think so. It starts from essential properties of phenomenology and then try to infer which kind of physical system would be able to account for those properties, and in that, and so it goes from these properties of experience, tries to infer physical postulates, and tries to come back and show that they are the same in some sense, they're equivalent or isomorphic. Am I going too slow maybe? Or it's fine.
I think it's okay. But one thing that I was curious, what did Tononi do before he proposed this?
So he, I don't know too much about like the more early so he's a
The early
psychiatrist.
Tononi.
Yeah, the early, yeah, he's a psychiatrist.
Mm-hmm.
And he did his postdoc, I think, with this guy, Gerald Edelman, and he worked in his labs. And then at some point they published this book called The Universe of Consciousness, in which many of the ideas are already there. They had like this dynamic core hypothesis. And then they kind of like something happened, and then Tononi just went by himself, like advancing and like trying to formalize the theory. And over like since 2004 until now, he has been like constantly like revisiting and doing like updated accounts and new versions of the theory. But he's like a psychiatrist by
training.
Yeah,
that's interesting.
And he normally like pairs with a mathematician and tries to like develop. So yeah, again, so what I think is kind of like the novel like gesture that IIT kinds of does is invert the direction of inference. You most like theories that came before looked at mechanisms and tried to kind of like say, oh, okay, this mechanism like synchronized gamma is consciousness because it always happens, so it must be the case that synchronization has something to do with consciousness. But you couldn't go much further than that. So what he tries to do is do the opposite, right? And so let's have a look at what those axioms are, which is so the axioms. The idea of the axioms is try to identify like essential properties of experience that are immediately given, that are general enough that any conceivable like state of consciousness follows it, and they should be, of course, like consistent and independent between themselves. And the tricky thing is that they should be complete. So you should also have like sufficient conditions for consciousness. So that's probably the tricky part. So the way you approach that, you try to like look at like concrete cases and in which like meditative states in which like people say that they, for example, don't experience, they can experience without no notion of like temporality. So maybe time is not actually, you don't need time to actually be conscious. So you try to like push to the abstract out properties and remain with those that are necessary. So what we get to that, IIT proposes that there are 5 of those properties, or it's like 5 or 6. You have first, you have existence, intrinsicality, composition, information, integration, and exclusion. Now try to briefly go through them.
Holy shit, that drawing is by Mach?
Yeah, I think so. Yeah.
Oh, I didn't know that. That's interesting.
Yeah. It's like the go-to drawing of IIT to illustrate the axioms for some reason. I've heard that his whole like philosophy on like sensory perception is really impressive, but I haven't looked into that. Probably inspired Tononi, I think.
You know, Mach is the guy I'm in love with, Bogdanov. He's big on Mach and Avenarius.
Ah.
Yeah, it's like his main. That's why Lenin hated him.
Yeah, and analysis of sensations is quite interesting, in fact, by Mach.
Yeah.
This is a book, Analysis of Sensations, you mean, right?
Yeah.
Yeah. Pretty sure it's like a favorite of Julio.
Interesting.
So again,
the drawing is impressive.
Yeah. Yeah, I think it was seen there.
Not
I
sure
love that there is a little mustache here, like
yeah,
the nose
like,
and the
yeah, and like this nose that you can.
Do we see this? I'm wondering, do we really see this? I'm not sure.
You can see your nose, and you can see
yeah.
I can see my mustache
point
here.
like this, I can see the nose and part of the mustache. Yeah, because he's lying down. So yeah, makes sense.
Yeah.
So I'll just be following like exactly how I try to like stay close to the text. So these are actually like the references that IIT uses across the text. So, so the first thing is basically saying consciousness exists. And it's funny because at this point, like many theories like would already like take part with like wouldn't agree with the first thing. Like would say, no, consciousness is an illusion. I don't know about that. I'm not sure. Like, so you already like lose many scientists at this point. So, but in any case, so what he's basically saying is that consciousness.
Sorry, Renzo. What did you just say? He's not committed to the idea of consciousness. I think I missed something in what you're saying.
No, I'm saying that like many scientists and philosophers of mind would not be prepared to like recognize and just like bluntly say consciousness exists and it's real.
Oh yeah, the opposite. Okay, yes,
yeah,
yes.
The opposite. So
you mean, but do you think the eliminativist crowd is the majority now?
No, I think there has been like a turn towards like non-reductive approaches, but I think it's 50-50 between more like not eliminativist, but reductive approaches, like more like functionalist approaches, like behind, which is the other big guy that proposes this global workspace theory. If you push him enough, he will probably saying at some point that consciousness is an illusion. Like if you actually like press him on that.
Yeah, because I see. I'm sorry to interrupt you because I'm interested in these issues. I mean, just somebody I have in mind, like Thomas Metzinger. He's not really an eliminativist, and yet he wouldn't say consciousness does not happen, but he would say something like consciousness is not the final explainer for things. Like it's something to be explained by other stuff, and it is something elected by the system, by the in physicalist terms, more than the foundation of.
It's something what?
Sorry.
You said it's something.
No, I said consciousness would be something elected by the physical system in a sense, right? Mm-hmm. So it's not the same as like Churchland would say, like there's no consciousness, like you can maybe redescribe everything in terms of in physical terms. Mm-hmm. But Metzinger would say something like, yes, it really happens, but the actual self is not really yourself. It's like something elected by the system, right?
Yeah, I haven't read his stuff, but I'm aware that he has like this theory of that the self is an illusion. But I always thought he meant he wasn't talking about experience per se, but something like the subject of experiencing.
Yes, you're right. Like experience is very important for Metzinger. This is what I'm aiming at, like making a difference between somebody like Metzinger and somebody like Churchland that maybe would think that experience is just a byproduct. You could navigate without it in some sense, like while Metzinger wouldn't commit himself to something like that. But I'm not sure why I brought this up. It had something to do with these eliminativist crowds.
Because I think there is a nice distinction to be made here, because in more than one text I've seen this reference to existence to be connected with the assumption of causal power, right? There's even that video you sent us, there's even a reference to Plato there. Like to exist is to be the cause of something. So I think that, for example, you could say that many kind of weak or strong eliminativists are going to say that this might even be in some sense, but it has no causal power. Every causal structure will be correlated with something else, not with consciousness, right? But I think that the way I've read this stuff this far, like one thing is to say consciousness has causal power or it exists. The other thing is to say the I exists and has causal power.
Yeah, of course. Yeah, I see.
It's not a theory. It's a theory of consciousness. It's not a theory of self, like because there are some properties missing to arrive at something you could call a self.
Yeah, right? but this actually was warranted by the paraphrase of Descartes. There, I experienced therefore I am. So within Descartes' framework, it is it kind of requires a subject of experience, right?
It looks like it's evoking a lot more than like, it looks like it's putting like a lots of stuff that we are actually we're normally associate with consciousness, but as you like progressively see, it's actually like a really deflated concept of like consciousness.
Okay,
In the end,
that's interesting.
consciousness will boil down to a really like simple and uh, thing with like very few assumptions. Like,
okay. What I find interesting is that this quote seems to aim at something but get something else right, which is Descartes is also, let's say, a very important thinker of axiomatic, so in certain sense, I feel like this quote is more important for the fact that it affirms the proposition of existence rather than the fact that it affirms some implication,
yeah.
like it doesn't seem like the crucial part here is the therefore, like, but more the fact that you're affirming that this exists, you're starting from it, right?
Yeah. And I mean, at this point, it's also like important, this idea of the here and the now, and of consciousness something actual. So it's not to be confused with its history or something else. So I think in the cards also you get that point in which like you're kind of like you kind of like have to keep like doubting so you can like maintain this truth you arrive. You cannot like rely on memory or on something else. So there's something of that in which like consciousness is something that's kind of like it's like stuck in the present moment. It's about the here and the now and not something else. So this will like play a big role in the form as I'll show. Then you have intrinsicality. So the first and the second are normally like presented together, but I think it's useful to separate. So the second one, we'll say that consciousness exists for itself rather than for something else. So consciousness is not something that depends on some external like thing or observer for it to exist. Like the patient is there and it's conscious or it is not. It doesn't depend of something external to it, like probing and measuring his PCI and then making it conscious or not. So, and it's so like the main definition will be not existence in general, but intrinsic existence. You have like some kind of like perspective from which things are experienced. And here again, it's not a perspective that imply any kind of like I or ego or like subject that it's doing this kind of perceiving. It's just that you have this space of appearance. So you have a perspective. So in this sense, it's intrinsic because it's this appearance is self-appearance in consciousness.
Like this appearance is kind of constitutive rather than relational, right? Like the appearances themselves make a concretion in a sense, like they are the experience more than relative to a subject or something. You're aiming at something like that or not? Or am I understanding wrong?
Yeah, I think it's fully like immanent. It's not like some subject that is constituting an object. It's fully like all its determinations are internal to itself in a sense. So there's also kind of like a high degree of like transparency to it. Like everything that it's there and determines it, it's kind of also immanent to it. So then you have composition, which basically says that it has some structure. Like every experience is experienced not only from a point of view, but it's also has parts and so you experience like the left side of the space and the right side of the space. You have like objects and you have things, and even in like really simple experiences, you like of a dark room, you still have like locations in space, and so you have some form of like minimal structure that kind of organizes this space. And it also, and you don't have only like simple parts, you also have like higher order organizations in some sense. You have like a book and So a blue book, you have like the blue, you have the book, and you have something that's the blue book, which is not, it's something higher order. So next you have information. So it's, oh, this is wrong. Yeah, it should say that consciousness is unified. So I know, oh, it's information.
No,
Sorry.
it's
Okay.
correct, yeah.
Yes, yes, right. So so consciousness is informative. So this used to mean something a little bit different from what is written right now. But I mean, the current like formulation of this axiom is that consciousness is specific rather than something generic. So it specifies something, and by specifying something, by being a certain way, it differs from all the other ways it could be. So in this sense, that is, it's informative because it rules out other possible states, and it's only the way it is because it does this, it excludes other possibilities. Okay, so of course it's hard to say what are the other possible experiences, right? But you could think about like a dark room. The dark room is, at least the argument goes like this, like you experience a dark room, but it rules out all other possible visual experiences you could be having. So in this sense, this experience of the dark room is more informative than like a photodiode that would just be off, because it actually excludes a lot more states and experiences than what a photodiode that can only distinguish light and dark, right? And then you have integration, which says the consciousness is unified. And this I think means two things. It means one, that it's one, it's unified, and it constitutes like a whole. And also that this whole is irreducible to like an aggregate of its parts. You cannot like perceive the left. Perceiving like the whole scene is not the same as perceiving the left plus perceiving the right of the field. And it's really hard to conceive like experiences that are not that does not appear as one, even though you could like fragment internally, like fragment itself. It's still like one field of experience. Otherwise, it would be like two perspectives rather than one. So consciousness has also like this holistic aspect to it. It cannot be, it's not like a sum of parts. And well, finally, exclusion, which is maybe the trickiest one and the one with like more implications, which says that consciousness is bounded. Like it contains what it contains, neither less nor more. So you don't experience like, there's not like your experience and then your experience minus something like the book on the table, and nor there is like an experience plus your like the acidity of like your blood. It's something definite, and it's something like bounded, and it has like a certain like spatial temporal grain to it. It flows at a certain speed, and it exists as like a certain like scale, you could say. Yeah. So what's interesting is basically what's left out, I think, because like you just leave like so much stuff out, like stuff that, I don't know, like philosophy would consider like conditions for consciousness, like, are not like in the axioms. Like I think the most puzzling probably are like the Kantian forms of like space and time. There's like no mention to it apart from like maybe in the exclusion about like the spatial temporal grain, but it could also be argued that it's not actually like spatiality and temporality itself that's there. And conceivably you don't need a subject or like any form of like intentionality, objects, or reflection to have an experience. And yeah, so these are the axioms. So IIT will say that conscious experience exists intrinsically, it's structured, it's specific, it's unified, and it's definite, it's bounded. And so after this, what it tries to do, and this is the critical move, I think, more than the introspect, like the derivation of the axioms. They're not too controversial, I think. But here is where it probably gets more tricky, because it's trying to infer what kinds, imagine like what kinds of physical systems, like what kind of properties a physical system would have to have in order to for it to be like intelligible that that system is consciousness and has those properties, right? So and I mean, I think it's also like the discussion of how much like the phenomenological, like how is this translation possible, like, because you're talking about two domains. One is experience and the other one is like physical substrate, right? So there's some possibility of translation between those terms, like information meaning the same thing, like preserving like the same thing it designates in like phenomenology and applying it to like a physical substrate. But yeah.
But just to question this, it is possible to have consciousness that isn't tied to physical, of a physical. I mean, I just mean that the consciousness here is a formal. It's formally defined. So, does it need to have like a physical correlate?
Yeah. So what the first like postulate will do is actually like postulate the physical world. It will say it will be like a gesture that goes out from like first person phenomenology and postulates like, okay, there should be something like a mind independent world which can explain like, which can account back for consciousness. So that's like it's postulated that that's the case. But from within experience itself, it's kind of like it's treated as an inference. Like there are regularities in experience, so it makes sense to say that a world exists. But I think it's kind of like Cartesian in some sense, that it's the phenomenological axioms are like sure about consciousness, but it simply like infers a world that's able to explain. So I guess the axioms taken by themselves don't talk anything about like causal powers and worlds and the physical world, but that's what the postulates will do. So it will actually like specify a certain like physical substrate that could do it.
Because
so
the axioms almost seem like I mean, they fix certain properties that we are defining, like we are axiomatically defining consciousness, but we're still not talking about, let's say, any formal properties of structures that will satisfy those qualities we defined. So I don't think that there is, I mean, there is no sense yet to even ask the question, could this be done without a physical substrate? Because the whole meat of the formal apparatus is not introduced yet anyway. So
yeah.
Like, well, we know what our properties we associate with consciousness, but I mean.
Yeah.
I wonder why there wasn't a sixth axiom that says consciousness is physical.
Yeah, maybe it's actually, yeah, in a sense it's not an axiom, it's kind of like this bridging move, the kinds of so there is like, I think it's called like the zeroth postulate, it's not written in the papers, but we talk about it. It's like the zeroth postulate just postulates the world and says that it can account.
Right. Okay, so the zeroth one kind of does that.
Yeah. So
it's a postulate of materialism for.
Yeah, exactly. Yeah. So there's like some, I don't know if this is useful, like if I should, but I just figured like now we're going to like the formalization of those axioms into like physical properties. So maybe just like a brief summary about like probabilities, because basically that's the whole language of the thing. So we have like a probability function is like a function it's non-negative, and it sums to 1, right? It's you can, it's in IT it's discrete, but I mean, and then you have joint probabilities in which you have like 2 variables and which is like the probability of X and Y. Then you also have like condition probabilities, the probability of X given Y. And they're related through this relation, which is, I think, maybe an axiom of probability. And which relates like a joint event of the probability of X and Y happening is the probability of X happening times the probability of Y happening given that X happened. And when X and Y are independent, you can factor this out. P of X and Y is P of X and P of Y. You have also like something that's relevant is marginalization, in which a joint probability gives you like the full information about how X and Y are related. You get like information about the distribution of X, the distribution of Y, and the dependencies between X and Y. So when you margin from the joint distribution, you can get back information about X by marginalizing. You just like sum all over, oh, this is wrong, so you should like sum over Y, right? And you have conditional independence, which is like a mixture of those. And so X and Y are like independent condition of the knowledge of Z. This is like a relevant property for like causality, because if you consider that X and Y are like present states and Z is like a past state, you are basically saying that X and Y have like no instantaneous like relation causality between them. If X and Y live in the same time instant and Y is the past, then you can just look at the past. And so this is, I think, called like causal Markov property. And then you have like the definition of the expectation function, which is you have a certain, I cannot see my own. Yeah. And from the expectation function, you get the known like mean and variance of the distribution. So yeah, I mean, I guess it's defined on like a probability space. So it has like some formal like constraints on that, but it's not too important. So, I mean, X can assume is a random variable that can assume like some states. In this case, it would be just like a binary variable of 0 and 1, but that you can conjoin with like other variables that are other nodes in the network. Okay, so this is more useful. So the entropy is this function that looks actually like some sort of expectation over a distribution. So the entropy of the distribution is given by this formula, and you could look at this term as an information content. It gives you like the surprise of observing a certain outcome. So you can imagine like you have like this distribution here below. If you got like something that's really unlikely, you'd be really surprised that you got it. So it has a high information content, because so the denominator will be high, so this value will be higher. Whether if you get something that's really likely, like really common, you're not surprised, so it has like low information content. The thing is that distributions that are like peaked and instead of being like spread out, you might get surprised. You might get like information like sometimes, but that's rare. So on average, you get like lower information than if it's a uniform distribution. And so the uniform distribution is also like interpreted to have like the most amount of uncertainty to it, because basically any state could happen. It's like a maximal degree of ignorance about the space. So it's the distribution that gives you the less constraints over a certain space. And as you get information, as you extract, you can like update your beliefs and kind of like as you get new information, you could update and learn something, and then you would get like some distribution of less entropy. So that's like the Bayesian interpretation. So entropy. And this entropy function it's bounded and it's positive, and it's, as I said, it's maximal for the distribution in which you have a uniform distribution. So a uniform distribution is also called like a maximum entropy distribution, and it's equal to log n, because if you put this 1 over n in this formula, like you get so log n, and then you sum all the n 1 over n's, and then you get 1, and so you just are left with a log over n. So entropy scales with the number of states that the random variable x can have. So you have like more states, you also have more entropy. You have to extract more information about this state space to actually figure it out. Whether like a coin, which has only 2 variables, it has only log 2. So yeah. Okay, so this is just like a quick prior on what's like some relevant math. Okay. So yeah, so now the postulate. So I'll try to mix like the kind of like conceptual formulation of the postulates, which are like more like ontologically, like something like this IIT ontology about like powers, and then try to like furnish, like also like present also the formal, like the mathematical formulation of it. So they can be like separated, but IIT also has like its own like ontology of things and how it understands of like what exists. So it will say it will equate physical existence with cause-effect power, and it will follow like this eleatic principle, which is in Plato. It's like this eleatic stranger, which says I'm proposing as a mark to distinguish real things that they are nothing but power. So there's no sense to say that something exists if it cannot affect and be affected. So existence will be like equated with cause-effect power, because if something doesn't produce effects and it doesn't has any cause, there's no sense in postulating its existence in physical terms. So for now we have some kind of mechanism, and this mechanism is able to have effects and be affected by something. So that's what like existence is saying. Also, it will intrinsically will mean that this cause-effect power it's not something that's purely like relational or like extrinsic, but it actually has cause-effect power upon itself, so within itself. So you can only say something exists if it can only affect itself. In this sense, it follows intrinsicality. So in this case, this mechanism is also determined by its own state, for example. So it will define like physical existence in terms of basically a system is a set of mechanisms in a state. So it's a certain like substrate which has a certain mechanism, which based on the state it is in is able to like produce effects and be constrained by other stuff. So just like some context on how this already differs with like other approaches to consciousness. So the like more common and traditional like approaches to explain consciousness historically is you either would say that, okay, you have a network that's responsible for consciousness. So you have like some part of the brain that is responsible for like colors. It's because it's always that I show you a color it fires. So it's in some sense it maps something that is in the world that has colors, and it represents in some sense. So, and functionalists would do like something similar, which it will focus it, maybe representation is more about like the inputs. It's the correlation between like a certain internal state and an input. And functionalists will also like say that a certain experience plays it is what it is because it plays a certain role in the system. It maps a certain input to a certain output. So it could map a certain like sensory input to a certain like certain behavior or certain like cognitive function that it is doing. So consciousness is doing some stuff, right? And this is a bit different from, it's a lot different from what IIT is saying. IIT is saying that something is what it is, not by its inputs or outputs, but what kind of cause effect powers it has within a certain like space in an intrinsic manner. So I'll explain what does this mean concretely. And it also differs like from like embodied approaches, which will say like the consciousness is something like related to a certain like loop, like a continuous loop between perception and action or something like that, right? That maintains a certain like circuit with the environment and stuff. So, and so maybe at this point is different. It's important to distinguish like mind from consciousness, right? So I think embodied approaches work well for like explaining like cognitive functions and what one would call like mind or like unconscious processes that determines the system, but it's hard to explain how it could explain like an appearance per se. So the case of dreaming, I think is the most, makes the best case for this, like because during dreaming you're disconnected and you can still experience everything that you can experience in wakeful life, except, I mean, normally like dreams you don't have like the sense of agency, but you have also like how do you say, like you have also dreams that you have the sense of agency. So it's, I mean, it's really similar, and you get everything, but you're still you're disconnected, and so you have to, it's hard to imagine how you have an account of that if by appealing to something that's external to it. So you could say, okay, the external world, you needed you have to learn those representations in some sense. So through like learning and history and evolution, you learn those representations. But the problem of consciousness is about explaining its mechanism that gives it that actually like implemented here and now, right? So the exact moment that you're having the experience that you're dreaming, there must be something in the brain that it's actually like specifying consciousness, right? And then you have like objections to like functionalism, which you could imagine like all sorts of like crazy implementations of these functions that like the dwarf.
Or Lula. This guy's dreaming of Lula, clearly.
Yeah, or Lula. And I mean, so there are two problems. I mean, if you have like the Searle's like Chinese room in which you have like this guy inside that's doing like all the work, but it's hard to imagine like, so it structures the causal structure, the way that something is implemented seems to be relevant, right? And the other thing is that this function that maps input to output seems like too poor to actually like account for the complexity and the richness of experience. So IIT would try to account for all of that within, like, from the intrinsic perspective of the system. Okay. So now, so yeah, I mentioned like how, like something like a physical thing for IT is a mechanism in a state. So the fact that it's in a state is relevant because consciousness is about an actual experience that's happening here and now in the present moment, right? So it's not it's not like a capacity you could, so consciousness will be some kind of function that's dependent on the current state of the system. So it's not a general capacity because experience is actual. So it's not some kind of like average, some like broad like structure that exists throughout time. It's actually like continuously instantiated at every given moment. And it's not also like any sort of like dynamical trajectory or history of the system. There's only like the current state and the current experience, and it will be related to the way it constrains to the past and the future, but it's different from saying that it's the set of like past events or some kind of like trajectory that involves many time points. Yeah. So so
Related.
yeah.
Sorry, just a question that I don't know if this question makes sense, but does this have anything to do with like Markov processes in which no memory?
Yeah, I mean, it's the whole IIT formalism is actually like calculated on top of like Markov systems, which are systems that depend on the past up to a certain point, right? So it's like the Markov process. You need just like one time step back in time, but not like infinite amounts of time steps, right? It has like really reduced memory. So yeah, the systems that IIT calculates are like Markov systems, which are just like dependent on the previous state. So yeah, I'll show you what that is. Yeah, everything is Markov systems. It's Markovian.
Okay.
Yeah, it doesn't depend on the full history of the system, just on a finite number of states. So now, how do you assess like the causal powers of a system? It's not enough to just observe it, because so for example, you have like a light switch, and you like click the switch and then it lights, and then that's like a switch. And you have some sort of gate, and you're able to observe like the light going up and down, and then you ask like, what's this gate? And just from observing this, you could say, okay, it's just like transmitting like the signal from the switch. But if you just observe that, you wouldn't be able to distinguish this gate, and if you wouldn't know if it's an AND gate or an OR gate. So you could have two cases. You could have, maybe it's an AND gate and it only transmits the impulse if this inner switch is on, or it's an OR gate and it doesn't care about like the other state of the inner switch. So the only way to actually know what this gate is you actually like put if you like perturb it in all states and see what it does. Maybe, so reality doesn't necessarily shows you all states that the system occurs. Like you have dynamical systems that could like be like have fixed points and it wouldn't do anything, but you would actually have to perturb it in all its possible states to know what it's able to do. So it's causal constraints. So this is why this distinction between observing and perturbing is really relevant for IIT. And the way this is done for every given system, you would have to like perturb it in all possible states and see for every state where does it goes. So what you get is a transition probability matrix, which is basically a distribution given a certain like present state, where does it goes. So in order to calculate that, you have to, it's really, I mean, it's undoable for big states because the state space scales with 2 over n, right? So, but in any case, you have a brain to actually know what its causal powers. It's not enough to, what it's saying is not enough to just like put an EEG, just like look what the most frequent, you would just observe the most common states, but you wouldn't be able to know like the causal constraints of each given state. I don't know if it makes sense.
Mm-hmm.
Oh.
So here, 1 means it can transition with probability of 1 to the other state, right?
Yeah. So this is a deterministic system. It's logic gates. So, but you could also have like a probabilistic transition probability matrix. The important thing is that it's given a certain state it is in, it determines like the future states, right? And that's everything you need to calculate everything that integrated theory. So, but it's really expensive to obtain this. Like you wouldn't be able to get this from a real brain because like there are too many neurons and there are too many states. But that's what you need to get the cause effect power. So yeah, so in theory, like everything all like the constraints are inside this TPM. Now, the postulated composition will say that you have so within a system. So the first thing we did is like we traced out like a border. You have like an open physical system, and you trace down like a system. You consider like whether A, B, and C exists from an intrinsic point of view. So you enclose that, and from the like a mathematical point of view, you just like fix the states of everything that's outside. You just like fix that at background conditions, and you just look at this TPM that's like restricted to the set you enclosed. So there's no like anything, there's nothing outside. It's just like fixed. I mean, you can only see what's outside by the fact it has insides, but it's all encoded in this TPM. So you would then ask like what kinds of like mechanism it has. It could have like A, B, and C could be like intrinsic mechanisms. So like parts within the system that are something, but you could also have like higher order parts. So A and B could exist on top of A and B separately, right? So yeah, so this is like the classic, like the original IIT way to explain integrated information. it would like talk a lot about like photodiodes, like the whole beginning of IIT is about photodiodes. So you would like ask, okay, what's the difference between someone that like looks at the light and from a photodiode? Like both are able to tell the difference between some like a dark and a bright room. So the argument would go that, well, a person is able to distinguish so from the light being on, a person is able to distinguish. So the fact that, the light being on means all the other states that it is not, right? So it rules out a lot more states, like a person. Whether a photodiode is able to distinguish only two states, on or off, it has like carries less information. So this is like the old way to do, but I think it's intuitive. But then you could ask like, okay, but the camera can do the same thing. It can distinguish like many states, but you don't get like, but the problem is that from a camera wouldn't be able to, it carries information, but it wouldn't be able to experience its distinctions, because you could separate, you consider like an aggregate of photodiodes, right? And you wouldn't lose anything by this description. So you need some kind of integration. So just trying to give some intuition about this translation of postulates. So, so what we're trying to do is trying to like imagine physical systems and say, okay, this system, it couldn't be conscious, because even if it processes some kind of information, it's not conceivable that it could experience like a unified, it could not experience this information in a unified manner because there are no interactions. And the same thing from this fully integrated but fully homogeneous system. Like it's fully integrated, but everything, like each part does the same as every other part. So it's not actually like distinguishing anything apart from what a single mechanism does. So you probably have to lie somewhere in between. Okay, so this is like the intuition behind it. So I think, so I decided to like add this formulation, which is not like the official like IIT, but I think it's really useful for like general things. And this is like a formula, like a formulation and like an alternative version to IIT that, it's still integrated information, but it's based on information geometry. And it's a measure of integrated information, which is not state dependent. So it violates like the actuality of consciousness, but I think it's really nice and it's really intuitive to it. So, so first thing, you have like Kullback-Leibler divergence. So it's a measure of distance between probabilities. So if you look, it's similar to like an entropy. It's actually like, it's measuring like, given two distributions, you're trying to measure how well this Q distribution is able to approximate the P distribution. So say P is like the full model of a system. It's like it fully describes a system with all its causal influences. So it's this distribution, which is very similar to a TPM, right? And then the question is like, okay, can I approximate the system making less assumptions, like with a system that is more poor, like it has less flexibility to it. So you could picture this. So you have like this certain P distribution that describes the full system, but you would like to consider like a certain manifold in this probability space, which is more restricted. And you would like to see like what kind of distribution, Q distribution, can best approximate P. So what you would do, you would use like this Kullback-Leibler diversion, which measures how well Q can approximate P. So how well Q can model P, and minimize this difference. So you would search this space, trying to minimize across this family of Q distribution, which are like restricted, and see if it can approximate. If you can approximate Q with P, so if you look at the formula, if Q is exactly P, this difference vanishes and you get 0. Right? Mm-hmm. If Q was P, it's this divergence is 0. And you could get like you can always be arbitrarily bad at something, so you could just be like really bad. But this, yeah, so this is important. So you need some kind of like distance measure to do the following things. So the way these guys approach the problem is like you have like a full model which models like the evolution of the system. So this is the TPM, right? It encodes the full TPM. You have like a certain state and you have a certain probability that describes the evolution of the system to the next state. So it has all the information the TPM has. And then you would ask, okay, can I remove certain influences and still like retain like the distribution? So this is nice because it situates integrated information within like a wide range of measures in information theory. So for example, mutual information, it's given if you remove all sorts of like influences and you're just like asking whether there's information that flows from time t to time t plus 1. Okay. And the way to look at integrated information is that you allow every unit. So I mean, is it clear, this like diagram? So you have like a unit in X, like a given unit in a certain time. And
yeah.
Then, yeah. So one way to see it, integrated information, is that you allow for influences within the unit. So the unit is able to influence itself, to constrain itself, but any like lateral constraints you remove. And then you see if this kind of distribution is able to approximate your original one. And
right. So the full model is the in this divergence. It's the kind of the ideal or the thing you're trying to get close to when you explore this space, but you actually don't know it. You don't actually.
Yeah, you don't know it. So maybe it's a really like stupid system in which X1 doesn't talk with X2. So this model allows for like all the causal constraints, but when you go there and measure with this like poor model with no like cross influences, you see that you can actually model it perfectly. So you discover your system is actually not integrated.
Yeah, it reminds me a lot of like a stochastic gradient descent and like these methods of learning, where the distance, in this case, the divergence distance is like your loss function, like how far away are you from some task.
Mm-hmm.
And then a learning task would be to keep trying different transition probabilities until you minimize that distance.
Yeah. You could picture like the algorithm to actually like try to calculate this could use like some kind of descent that walks in this manifold and try to minimize this difference, right? Yeah. So integrated information, is when you try to like lose the constraints across units and try to measure how much you lost. So you try to minimize like this difference between a full model and a disconnected model, which is cross influence arcade. So yeah. So this will appear like more robustly now. So the full story, like so integrated information is trying to measure then the difference between your actual system and how much you lose if you cut it, right? So if it's not integrated, you should be able to cut it in a way that you don't lose anything. But there are different ways in which you can cut a system, right? So if you cut it in this horizontal way, it would appear that you lost, that it's really integrated, right? But so you have to look at all ways you can cut the system to actually know how integrated it is, because there are ways in which it looks integrated, but that's just because you cut it in a vital way, but that doesn't mean that there wasn't a cut that actually, if you cut, you lost nothing. So that's why it's a minimization across all cuts. You have to actually like search for this minimal information. It's called like a minimum information partition, which is like the cut that makes the less difference. So if there's a cut that makes no difference, then there's a cut that can separate the system and you don't lose anything, then the system is not integrated. So how much integration you have is actually a difference between your original distribution and a certain cut. And this is in some sense related to an entropy. But this is like the main like central intuition about like calculating integrated information. It's a difference between an intact system and this minimal cut that makes the least difference to it.
Yeah, is this at all related to either compression or Kolmogorov complexity, in the sense that you're kind of trying to find the minimal system to explain something?
So it is true that in terms of, at least if you think about like, so you normally like think about Kolmogorov complexity, I think. So in PCI, you're looking at Kolmogorov complexity, something like it. So Lamp-Positive approximates Kolmogorov complexity, okay? So this Lamp-Positive is actually like an algorithm, an empirical algorithm for Kolmogorov complexity. So the Kolmogorov complexity is like the minimal description you need, right? To describe a certain sequence of states. So in this case, you have like a certain like history of like spatial temporal states, but at least, but integrated information is it's state dependent, right? So it doesn't care about this history. So if you take it as like Kolmogorov complexity of the history of a system, which is like the way it's normally used in like your science, like you try to look at the entropy of a certain like observe systems and try to compress it. So I don't know if.
But I think that this actually touches on the first, let's say, big conceptual jump. I think. I mean, the axiomatic approach is it seems like a new strategy, but the fact that in IIT you're interested, I mean, you're associating consciousness to the causal power of the mechanism and not to directly only its complexity, right? I mean, you're interested in, let's say, intrinsic constraints. So you don't want to measure simply complexity and through compression, because you want to measure complexity and connectiveness, right? So it's not simply interesting to know if something is highly complex in the sense of it has a lot of crazy parts or whatever. You also want those parts to be connected. I think Kolmogorov, I mean, that's even Ippolito's text. That's the main point, right? It's you want some way to measure complexity where total randomness is not really the maximal level of complexity. You want to sort of, it's a slightly different concept of what counts as complexity. I mean, the idea that you are interested in the partitions and that it be connected, I don't think it follows directly from, I mean, that's not necessarily measured by Kolmogorov complexity, right?
So yeah, maybe, so PCI is I think a good way to give intuition to this. So you would like to distinguish like a random system, which I mean, in terms of complexity is the highest possible if you have just like pure randomness, from a system that has structure, like causal powers, right? Which distinguishes itself from a maximum entropy distribution.
Mm-hmm.
So that's the problem. Like you want to distinguish like the good complexity from the bad, the complexity with structure from the complexity that's just like an effect of noise.
Mm-hmm. So
one way to do this is perturbing. So you actually like knock the system, like put it in a state and see what it does. So a random, like a random system would always act in a random way. So it's unpredictable. So actually the strategy of this PCI, you perturb it like 200 times and then take an average.
Mm-hmm.
So if every time it did something different, the average would be zero.
But it's a perturbation that accounts for the fact that we're taking a look at good complexity and not bad complexity, right?
So it's maybe two things. You're like perturbing many times to know that it's reliably going in a deterministic way, right?
Mm-hmm.
So here you can oppose determinism. Determinism gives you structure. It means that the system is not random. So one way to measure determinism is like you knock on something, you perturb something many times, and if it does the same thing over and over, it's not random.
Mm-hmm.
Otherwise, if a system was a coin and you always like perturb and it would give you like a random thing, it wouldn't be deterministic. So it's two things, right? You perturb and do it many times so that you can extract the distribution. If this distribution is random, then you know it is because it will average out as something non-deterministic. And then, so PCI, in both cases, so that's the difference. In neuroscience, you actually like calculate Kolmogorov complexity, which is like Lamposive of like resting state EEG. You just observe the brain and just like try to compress it. But you don't know if it's noise or if it's the deterministic interaction of the brain. Maybe it's just like, it's non-relevant. So and at this point, you wouldn't be able to distinguish the structure complexity from the unstructured one. And as a matter of fact, like if you just like simply compute Kolmogorov complexity of like resting state, like continuous EEG without perturbing, it performs way worse than like perturbing and compressing. So it depends like how you, like on what you calculate complexity, because you must be sure you're not looking at randomness, right? But all this is still different from integrated information, because integrated information doesn't care about like, I mean, it's not different, like it's tied in some way, but it's really tricky. So you certainly need causal powers in order to produce spatial temporal complexity, but spatial temporal complexity is not like a necessary it's tricky. Like you would have to formally tie like the dynamics of a system to its TPM.
Yeah, because I mean, very naively, the way that from what you explained this far, the way that I would summarize it is that it seems like integrated information, it measures the capacity of a system to perturbate itself. Because if you're measuring, let's say, the difference between the distance between a certain state and let's say how it can be constrained by what happened before and what happens afterwards, it's not really dependent on experimental perturbation and let's say certain experimental guarantees that you're not really acquiring random data to be measuring structure.
So one thing is how you calculate the causal constraints, but the system itself doesn't need to to experiment with itself. Like you just assume that like for example, a logic gate, it doesn't need to perturb itself to know that it's a logic gate. It is what it is. So the way it's interpreted, the fact that there's no need to the system actually explore its states to actually know. It's just an AND gate. Just if it receives an so one way to put it is.
But
so,
don't you know I mean, you formally know the amount of states that this logic gate, this logical small mechanism can have.
Yeah.
Right, as you said, the TPM requires either observing all states, which is not realistic, okay, but perturbing all
yeah,
the
but
power set of its state.
From the external perspective, from the intrinsic perspective, the system literally is the TPM.
Yes, yes.
Yeah. So it doesn't need to. So someone from the outside, if you would like to have know what a system does, it would have to perturb. But the system itself
sure.
literally is the TPM
Mm-hmm.
and nothing else. Yeah. So yeah, I'll start to get more closer to the actual forms. So, yeah. So the definition of information probably comes from Bateson. Like it used to be defined that way in IIT, but they dropped that for some reason. So information is the difference which makes a difference. So in the case you have a certain state, like a firing of a neuron, that makes a certain difference to like it produces effects. So there's a certain difference within a neuron. It could be anything else, but it is the case that an actual potential is able to influence the state of other neurons. So there's a certain difference which produces certain effects. And the fact that the neuron is a certain state, if it's silent or if it's firing, it kind of knows something about what kinds of states it was in the past, right? So say if it fires whenever a connected, so I'll show you more like carefully. So take this case. So the most important concept is probably, so now before I didn't mention any state. So these are all like averages. So this formalism doesn't care about the state the system it is in it. This is measuring like a general capacity for integrating information. I don't know if it's clear from the formalism, but now we're looking at actual like state dependent measures. So you want to check a certain system. It is, so take this system, this really stupid system, which is just like copy gates. You just copy what the other one is. Okay. So it's already interesting, like this stupid system. So this system, the dynamics of it would be super simple, right? It would switch states between itself. It would just like be on, off, because X1 copies X2 and X2 copies X1. If you would initialize the system both on, they would just stay on, right? And so what is like a cause repertoire? A cause repertoire is even a certain, like a mechanism is in a certain state, how it constrains its past states. So take, for example, this X1, this unit, the fact that it is on, it knows the other unit was on in the past, but it doesn't know, for example, what its past state was, its own past state, because it just copied his friend, right? So the cause repertoire in this case, if you can look here, it's how it's constraining like over its own self and the other unit. He know, like the system knows by being what it is, that it was either like his friend X2 was necessarily on. He knows that for sure because he's a copy gate, but he doesn't know if he was on and off, because there's no way to know that just from the state he is in. So, but this is some information, right? So this is better than just not knowing at all. which would be like a maximal entropy distribution. So a way to measure how much information like a certain state gives you, like how much causal constraint a certain state gives to you for being having a certain mechanism, is given by this distance between a fully unconstrained and a constrained version. So had he not known the state he was in, he could have come from any state. So his past would be completely like indeterminate. But the fact that he is in a state constrained the space of past states into like a more like definite distribution. And the way you measure this cause information is different, like a distance. It could be like the Kullback-Leibler distance. So you're measuring like the constrained repertoire towards an unconstrained. So how do you know that you're determined by your past? If the state you're currently in tells you something about your past states, above and beyond like what randomness could tell you, then you have information. You have like some sort of like causality, right? So this is like the main, like most important concept probably, to calculate everything else, and like all those things, it all derives from this cause information.
So does this connect the dynamical viewpoint to the integrated or intrinsic viewpoint?
Yeah, I think it's tricky because so again, you could maybe, so imagine these two copy units were on.
Mm-hmm.
In terms of dynamics, you would observe it forever on, right?
Right. Yeah.
It would be completely, so take both of them are off. They are a completely inactive system, but it has cause information, because were it on, it will have a certain dynamic. So it's, you see how you can dissociate dynamics and cause information. So the really like non-intuitive thing about like IIT is that even like an inactive network of like fully like silent neurons have cause effect power. The only way to like destroy causal powers is to actually like remove the connection, right? So it's not about the fact that something is active and has like interesting dynamics that it's actually saying that what it's capable of doing.
Okay, but with the perturbation approach, how are we getting this cause information?
So in a perturbation approach, so say you stumble upon this system which is always on.
Mm-hmm.
And you say like, oh, it's the most simplest thing in the universe. But if you perturb it in all states, so 0, 0, you turn it off, and then you put it on and off, and then you see it has actually like a certain logic. It has constraints over each other. Like one copies the other. So
I see. Yes, because they would have some probability correlation. Like there'd be some statistically significant interaction.
Yeah, like
between these two values here.
If you perturb in all states, you can actually see the logic of the mechanism. Whether if you just observe it, you cannot. It's just simple. And this constraint over the past states is not at all in this case tied to the complexity of the dynamics of the system. But you can mathematically like prove that in order to get complicated dynamics, you inevitably, in some sense, have to like integrate under certain constraints. You have to integrate you have to have causal constraints. So they're tied, but you can dissociate them. Yeah. So yeah, this is another example. So say you have like an AND gate, but you have a lot of noise in this reception. So it's an AND gate, but it cannot tell apart, like it's just too noisy. So it's completely unselective. The fact that it's on gives you no information at all. And you can try to a fully like deterministic system. The fact that this AND gate is on, it knows for a fact that in the past state, these 3 units were off, right? in this immediate past. So it's not that it observed the history, it just knows by the current state what happened in the past. So this is what like cause information is. And if you measure the difference, so there's a big difference between this super selective state. The state can distinguish, like fully specify what the past state of 3 neurons were, because it's firing. And it only fires in that case. So the fact that it's firing gives a lot of information. So this has really high cause information. While if it's silent, well, you know that probably, well, either all of them were off, or maybe one was on, or maybe like 2 were on, but you just know for a fact that it wasn't the case that the 3 of them were on. So there is some information you get by the fact that the end, this A neuron is off. So you have less cause information in this case because you can tell less, you can constrain less the past states. Yeah. But you have to have like both past constraints and future constraints. So take for example this end node, it constrains its past, like it knows stuff about what's happening in B and C. So it's selective towards its past, but it doesn't it doesn't produce effects. So in terms of an effect repertoire, it doesn't do anything, like it cannot constrain anything. So it has no effect information. So that's why, and in this case, you could also have like a gate which does the opposite. It's not determined by anything. It's just like a random thing, but a random coin that can produce effects. So in this case, it would have like high effect information, but no cause information. And integrated information is like its definition of existence is having both cause and effect powers. So you have to have both. That's why you take the minimum of cause information and effect information. So certain mechanism has to be selective over its effects it produces and over its causes.
In order to have this intrinsic existence, right? It's not a good quality of things existing in general, but for them to exist in this intrinsic way for themselves, right?
Yeah. And I mean, once you imagine like what neurons do, it gets more like concrete. Like a neuron, it's only this machine that's able to like the fact that it is firing, because the synapse as it maintains, it knows something about like its constraints. So there's only what there is to its information, like it's carrying something. It's able to produce difference and be affected by something, and that's like the way you can calculate this stuff. So yeah, so this is just like an example. Let me see if this is useful to go. So formally you have cause information, which is this difference between unconstrained and constrained repertoires, right? Between the probability of a system in a certain state compared to as an unconstrained distribution. And then cause effective information is just the minimum of both, because you have to have, if you have 0 of one of them, then you have 0 cause effect information. And then effective information, which is like the central concept for like hollow stuff, is basically an average across all states of cause information. And the difference again is now effective information is not state dependent. It's just like a general capacity of the system. So it measures, it is a measure of its, I mean, I can show you another time that it's the difference between how a deterministic term and a degeneracy term. So if you average across all states and all states gives you cause information, it means that the system is deterministic, like in some sense, because over all states it constrains its past, so it has cause information. And then he will show that you can actually factor this formula into like a degeneracy term and a determinism term. So whether it constrains the deterministic way its future effects, and whether it knows where it's coming from. So it's actually a difference between determinism minus the degeneracy. So if a system doesn't know where it came from but determines something, it wins something and loses something. So ideally, if you are fully effective, you're not degenerate because you know where you came from, and you are deterministic because you know where you're going to, right? So that's what effective information is.
Just to clarify, is the unconstrained case always random? Like
yeah, that's a good question.
1 over n?
So, for cause information, yes. For effect information, no. So for effect information, it's a little bit more tricky because it's about the future states, right? So what you have to do is actually put the system in all possible states and observe the future distribution. So the unconstrained effect distribution is actually like you enforce like a maximum entropy, like a 1 over m distribution, and observe where the system goes. And that's your unconstrained effect distribution, right?
Okay.
So if a system just like randomly converges to one state, then that's the unconstrained effect distribution, because that's the way like the system randomly goes to. So the effect distribution is a little bit different than the cause. But yeah, in general, like unconstrained distributions are like maximal entropy distributions. But yeah, there's a different though. Yeah, so now we have like we have a way to calculate how much information a given mechanism have by being in a certain state. And if you average that out, you get like some sort of like effective information that goes through that node. How much information that node is able to process. So you just like average across all possible states and see if it has high degrees of cause information. And then what Ho would do is like try different coarse grains of the system and see where does this effective information is maximized. So maybe there are like coarse grains higher. So the interesting about like coarse grains is that you lose your state space becomes smaller because you're coarse graining, right? So you lose the size of your state space is smaller. And so the smart thing is that maybe by coarse graining, you lose state space, but what you lose in the number of states, you gain in effective information. So maybe
really crazy.
Yeah.
Is the coarse graining the thing where you take like A and B together and consider that one?
Yeah, you do some sort of, yeah.
Okay.
Some
That's the complex, right?
Yeah. Okay, so now we know how to like calculate information, causal information, but now we have to check whether this given mechanism is irreducible. So the postulate will say something like a system and its mechanism, the cause effect structure must be reducible to that of its independent part. So, and at this point, like Tononi cites Leibniz in an article, which is interesting. I think, yeah, Julio likes Leibniz a lot. I know that because he always mentions like the principle of sufficient reason and he likes like Kant and Leibniz a lot. And I know he doesn't like Hegel, but
who does? But
yeah. So like brace yourselves. It's almost. So now, I mean, it's you wanna so also see if like certain parts within the system are also like irreducible parts. So take like A, B, and C. You also want to know if A, B, and C exist as an irreducible part of the system, right? So the way you have to know whether A, B, and C exist as a part of itself is you partition it. So what you look, instead of comparing like these cause repertoires and effect repertoires to maximum entropy distributions, you compare it to like partition versions of these mechanisms. So this higher order mechanism it's interesting because it has a lot of determinism. So remember we were like, so if we consider like this full high order mechanism A, B, and C, A it's on, B is off, and C is off. A is an OR gate, B is an AND gate, and C is an XOR, so it's exclusive OR. It's only on if either A or B is on, but not both of them. So the fact that they are in this state, it's, if you just like think, reflect a little bit, you know a little bit about the past, like kind of a lot, but not everything about the past of this system. So you know, so this is on, the OR is on, so you know either B or C was on. The B is off, so you know that both weren't on, and C is off, and you know that it wasn't the case that just one of them was on in the past. So what you get is either, so for a fact A and B were on, but you don't know about C. So if you look at the cause repertoire, so is that right? Does that make sense? So the only state that can come, so
either A and B were on, or C was
so let's
on.
say A and B was on and XOR was off. You would evolve to this state, right? Because, but if C was on, you would evolve to the same state, right? If you had A on, B off, and C on, you would go to this state. So this current state, you cannot distinguish the state of C from the current state. You know you know like the past state of A and B, but ABC as a higher order mechanism doesn't know the past state of XOR. So this is the cause repertoire, right? But the interesting thing is that it's not symmetric, like so. But the fact that it is in this current state, it fully constrains the next state. So you could just like derive like the next state of the system was in, which is
C will be on.
C will be on, yeah. So, and then what you do, you measure the difference between, again, unconstrained repertoires here and the unconstrained effect repertoires, and calculates, but the twist to each is you don't compare to unconstrained, you partition the system and see what it loses. So you consider like cuts in which you noise, like the dependencies, you get like disconnected models, like you enforce by injecting noise, you can remove the dependencies and see how much you lose. So maybe this information that A, B, and C have could be reducible to the information that A has and B has and C has. If the product of the like elementary mechanism, if you could recover the cause effect repertoire of the higher order mechanism just by considering like the cause effect repertoires of the separate elementary mechanism, then the higher order mechanism doesn't really exist. Like we thought it was constraining, but it was actually just its parts that was doing the work.
So this is where the atoms, there's some overlap between the generativity thing that we were discussing a couple times ago and this, right?
Yeah, exactly.
If there has to be an inequality between the sum of the parts and the whole for there to be a generative effect.
Yeah, and exactly. So this is, you can always think of this distance as a difference. So a difference between so like the generativity, you had like phi of A plus B. You could regard that as the full system, like the intact system is different from the phi of A plus phi of B, right?
Exactly, yeah.
As the partition mechanism. And you do a difference, and if this difference is 0, then you have equality, and it's 0. So precisely this is the way that you measure integrated information. So the thing to note here is that we're considering mechanisms within the system. So we're not asking, so that's something that's kind of like weird about IIT, and it looks a little bit useless, but we're asking whether a given part, which is a mechanism, exists in a reducible manner within the system. So now we're measuring like integrated information of the parts of the system, but not the integrated information of the system itself. Which, I mean, I'll try to clear that out. But yeah, so what you actually have to do is like partition all the cause and effect purviews and just like try to like cut all possible ways. And you get problems because the partitions like grow like factorially. So, I mean, like integrated information is like completely like untractable to calculate for any system with more like than 12 neurons because you have to like calculate like a TPM, which means like perturbing null states and then cutting like the hell out of it. So it's just like it's this measure that is unfeasible. So it's yeah. So, and the reason is because you have just like to cut in all ways and just like perturb everything just to, but this is to measure from the outside. Again, the system from within itself, it doesn't have to do that work. It simply is these constraints and nothing more. And it simply is the reducible constraints it have. So, which are, yeah. So finally, okay, and now the final postulate, just like the most weird one. So a system must be definite. So that means you cannot allow for like it to exist at all subsets and subpersets. It cannot exist at all spatial temporal grains. It must exist in a given like definite way. So a way to find that out is like, what is the maximum across all these scales? Like, where is the reducible cause effect power maximal? At what scale and at what temporal grain and what subset? So the way that like Tononi argues that in like a more like philosophical paper is this. But which out of possible overlapping entities should actually exist? The entity that actually exists should be the one that lays the maximum claim to existence, precisely by being maximally reducible as compared to its subsets or supersets and different spatial temporal grains. The same cause effect power cannot additionally support overlapping entities. Otherwise, existence would be multiplied for free. So there are like many arguments at work here, I think. So let me, yeah, maybe we can discuss the arguments later. I'll have a slide for that later. But formally, like what that means is that you actually like, you want to see which like causes over which units a given mechanism is most irreducibly like effective over. So, I mean, it could be connected to many stuff, but we want to see over its like connected units that it could produce an effect over which of this cause purview and this effect purview it is maximally reducible, right? So it will select one of them and look at this maximal effect power, and it will say that the other ones doesn't exist. So this is like the full definition of a mechanism of a what's called a distinction, which is similar, I guess, to what an atom is. Like it's what an irreducible part of the system is. It exists for the system because it has cause effect information in an irreducible way, in an intrinsic matter for the system, right? So the full formula would go something like, it's a distance between the cause repertoire or the effect repertoire and its unconstrained cut version, not unconstrained version, but cut version. And which cut? The cut that minimizes this difference. So it's the minimum information partition, right? So the cut that makes the least difference for a certain like mechanism. So if you find any cut that this is zero, any cut that doesn't make a difference, then this difference collapses to zero, and then you lose all information you had. Furthermore, you want to maximize, although you want to find a reducible difference, you want to maximize over which like units you have your effects and causes. So you also search for over everything that you could produce an effect on. So let's say, so the metaphor that we use is like, you have like a carriage of like horses, and you have like reliable horses and non-reliable horses. So if you have one horse and it's fully reliable, then it's great. Like you're fully effective over that horse. If you add a second horse, if the second horse is like fully reliable, then great. Like why not? You have like more power. You would add that. So you get more. So you would augment your effect purview in this case. You would just like add a horse. But if you add like a horse that's like, okay, sometimes it works, sometimes it's not, like kind of like a handicap horse, then you don't want to like consider it like part of your effects. You would just like throw it out. If you have like really unreliable horses, you'd say, okay, my effective horse is just like my good horse. I don't have effects over that bad horse because it's too bad. So the distance you actually use to compute these differences, and it's like the for IIT 4.0 is this intrinsic distance that took like a long time to like develop and come, and it's not the Kullback-Leibler distance. It's a distance that preserves this property in which if you add horses, reliable horses, you how do I explain this? Is a distance for which you like select horses that are reliable, but you don't add for free like useless horses. So it's a distance that scales with the number of units you have effects, but it only scales in like reliable units, right? It has this property, and it was like designed for that because that's like the intuition behind being like maximization of effectiveness. So if you're a neuron and you produce effects, you're just like consider the neurons. If you're connected to like a useless neuron, you wouldn't consider it as part of your like effect purview, as part of your cause effect power, right? You just like consider like reliable units.
So is this the idea of core cause that they present in that paper?
Yeah. So the core cause will be the maximal purview. So over all possible subsets, over the power set of your causes, you're looking for the one that makes that you're maximally irreducibly effective. And this maximal one is considered your core. Now it's just called like your cause purview, but yeah, it's the core effect. The same for the core for the effect, the core effect and the core cause. So in this formula, like you get like the three things: exclusion, integration, and information. And again, you have to have that in for both effects and causes. So you get like the minimum of over this, both of this. And that's what small phi is. Small phi is the amount of integrated information of a certain part of your system. So yeah, this is the picture in the paper, right? So after you go over this process of like minimization of over cuts and maximization over like purviews, cause purviews, you identify whether this part exists from the point of view of the system. From the point of view of ABC, A exists as an irreducible, maximally irreducible part, which is called the causal distinction. Yeah. So, and now you do that, you repeat that for like for the power set of the part. And then you find out, well, you have higher order mechanisms, but A and C is reducible. A and C is reducible to B and C. So in this case, this is like an interesting system. Like it has higher order distinctions, but not all of them. And they are irreducible. The amount they are reducible is this small phi. So all these composes like the parts, like the irreducible like components of the system, ABC. And now like the new version of IIT has also relations in which you measure, which is not in the 3.0 paper, it will be like in the 4.0, which is, it is already on the space paper, but it will ask whether different distinctions constrain in similar ways their cause and effect purviews, whether they produce constraints that are like consistent between themselves. So relations are given whether like the effects of different parts agree on the future that they kind of like constrain. So if these constraints are like coherent, there's a relation. And again, it will like test for like irreducibility, maximality, and all this stuff. And in the end, you get like a bunch of like distinctions and relations that constitute what exists from the point of view of A, B, and C. Which is like, and this is what a cause-effect structure is like a set of like causal distinctions and relations. And these relations can also be higher order and there are like all sorts of different like ways to constrain past and future. But so at this point, we just assume ABC existed as a system. We didn't actually, we tested for its part, but not a system. So we tested its parts, but not it as a whole. So the full IIT algorithm like tests for both things. So okay, and exclusion again, this is like relevant, I guess, for it's like the interesting stuff which Ho will explore. Is you do this search for like this given scale, but you would also need to ask whether this is like the best scale like that integrates information. So maybe if you just coarse grain a couple of units, you get more like integrated information. And exclusion will say that, well, then there's a higher scale at which like things exist, as opposed to like a finer scale. And the same is done for different time scales.
Again, to coarse grain is to collapse different points into one. That's a procedure.
It's, yeah, but you do that by some sort of like, maybe you have to define a function to coarse grain. So
yeah, of course.
So yeah, I have to study that again. So I could.
Okay. Okay. No,
have something.
This is interesting. This is very interesting.
Yeah.
This coarse
So
graining procedure.
yeah. So there are many ways. They call it also black boxing. So you just like pretend that a certain like
black boxing.
Yeah, black boxing.
So you are kind of losing information when you collapse one into the other.
Yeah.
This is why. Yeah. Okay.
Yeah.
Yeah, but the crazy thing
if
about
you lose
it
information,
you might lose extrinsic information, but gain intrinsic information.
Yeah, exactly. Yeah.
Yeah, I would say it's the opposite, but okay. Yeah, maybe I'm
No, I mean that's the weird thing about it, that you can coarse grain a system to find that at a coarser grain, the effective information that is intrinsic to that system is higher than when you got
it's more visible than it's more visible than the inferior.
Yeah, but the visible, not in the sense of for me, but for the system, in the same sense that Hansel was talking about, that its capacity to, let's say, store its past purview and future and effect purview, that will actually be richer. So it's not for us. Like for us, it might be, okay, I can zoom in and get more info.
Yeah. Yeah, I mean, a reductive approach, like that's the intuition behind reductive approaches, right? If you have like the full micro state, then we have, from the extrinsic point of view, we have everything we need. But the question is whether for the intrinsic point of view of the system, whether it has more information about itself, more effective information, if it considers itself as like this micro at the finer level or at the coarser level. So one like really like concrete way to see that, so like consider like this network of neurons. So you have like this code in which you have like 4 different states. You could have like firing rate and you perturb the system and you see whether the firing rate of the neurons like doesn't changes, maybe it decreases, maybe it increases, can burst. But every trial you perturb, if you look at the micro level, like not all like neurons do the same stuff. So at the micro level, it's not like fully deterministic, right? You like from trial to trial, like the micro levels, they sometimes they like increase firing rate, but sometimes they decrease. But were you to consider like a coarse grain in which like you consider them as a group, like you do like some sort of like majority processing, which like the you consider something is firing, whether if like most of them are firing. So so this macro state is an increase of of firing rate if most of the states are like increase. Otherwise, it's not. So that's what like coarse graining means. Like you define a function that maps this finer grain to like a coarser state, of a macro state.
Yeah, and also maybe we can think of it as you're a function that takes one transition probability matrix and reduces it to a smaller transition probability matrix, right?
It is exactly what Hole does, right?
Yeah.
In that Mexican territory.
If you look like these
okay.
coarse grains, then suddenly the system becomes very deterministic. Like you perturb this node, the network always does something consistently. So that's what I was talking about, like perturbations and doing repetitive, and then you're assessing cause effect power and determinism and the degeneracy. So this system might be like, we might look at neurons and find that they're like, individually they're noisy, but they are connected in a way in which like groups of neurons are really like, carries a lot of effective information. So the idea is that probably there's a level at which neurons are like the most effective as a code. And that should be like the level at which consciousness appear, right? And the same thing for time scales. Maybe if you look like, so if you look at the system at like really like long scales, like every second, you lost all information. Like if you sample it at the wrong time scales, you might get like either too much noise or like, yeah, you say so take it, for example, this time series of like different neurons. You perturb and then they fire and then it looks pretty noisy, right?
Mm-hmm.
But if you look at a longer time scale, like 100 milliseconds, then suddenly like the neuron on average, it kind of like fired reliably, like as taken as like this increasing firing rate. So maybe firing rate is a difference that makes more of a difference than a single action potential. So that's how you would like test for. So you would have to like check integrate information on these different time scales and see where it maximizes, and also these spatial scales. And now, like, okay, now we have distinctions and relations and like maximally reducible like distinctions and stuff. But now we have to check whether the system as a whole exists. So, and that's how you get like big phi, which is like corresponds to like the level of consciousness. You would like try then partition the distinctions and relations of the system and see how much you lose. And then you would look over like the overlapping systems and see where there's like a local maxima of phi, of like system level integrated information. And the idea is only like, and a complex is a local maxima of this irreducible cause effect power at the system level. So you could maybe have like a different like overlapping system, which has its own like irreducible, maximally irreducible mechanisms. But there's like a slightly bigger complex system in which you have like higher amounts of phi, and this means that it would exclude the subset, and that should hold also for the subpercent. So and I'll try to like argue like, so what are the arguments behind the need of this like really aggressive exclusion principle that just like makes stuff not exist. So the picture you get is like, you only get integrated information in recurrent networks. You cannot get like, so if you have like motor output and like sensory input, they are all like feed-forward networks, which they either don't have like cause information or don't have like effect information. So they're always reducible. Feed-forward networks are also always reducible and thus they don't integrate information, thus they can't be conscious. So you already exclude everything that's feed-forward. So one big like implication of is that like computers, as they are built today, in feed-forward, really parallel, like feed-forward manner, they cannot integrate information, so there's no way like it could be conscious. So you could have like complex, which are like, so you could picture like the brain, you like calculate phi for like everywhere, for all like the power set of everything over all scales, and you find a complex. So dynamically, you could imagine that it could shrink at certain moments. So say you're like fully like concentrated on a movie, then it could like, this complex could like dynamically like move. The peak of integration is over like a posterior zone. And suddenly like you start to like engage in like abstract thinking, and then you suddenly are like less conscious about like the surroundings, and then maybe this complex like moves to another place and maybe shrinks a little. And you could also conceive that there were like functional splits, like maybe if you like drive while like you think, you'll listen to music while you're driving, it's conceivable that there's like a split in integrating information, so you have like two complexes. Or you could do that.
So
like,
there's just pause a little bit. There's an underlying idea then that the integrated information that is consciousness might have an isomorphism to what, brain cells or so. Yeah,
we'll get there.
This is the idea. Like it's kind of an identity theory between mind and brain also.
Yeah. So the crucial thing is not an identity between what we normally consider to be a physical system, but it will be an identity between its unfolded cause-effect powers. It will be
like an identity between organizations. One organization which is in a physical, an organization of, I don't know, neural correlates, and an organization of what we call phenomenal experience itself. So you're trying to do a mapping between these, like one kind of organization, and I mean organization in this multiscalar sense, right? So it's kind of a mapping between an organization and another organization. One is the phenomenal realm, another is a physical in the brain realm, something like that.
It will be, it's the central identity, So
it's not just an identity theory in the sense like brain states, certain brain state X correspond to experience X line, but in the sense of a second order isomorphism, like.
So technically, it's like an explanatory identity. So what is primary for like IIT is consciousness, so phenomenology. That's like the measure of being. And then
this is what I'm aiming at, because it is kind of interesting, because you try to explain, you started by explaining a certain consistency within the phenomenal experience. You didn't start by explaining, I don't know, brain cells behavior, right? Yeah. So it's kind of because of certain properties of the phenomenal realm, you go then to map these onto certain second order properties of, I don't know, brain cells or their entanglement within these systems you are describing. So is it something like this, very naively put?
Yeah. So, but it's not an identity between like brute brain states.
Okay.
Like, it's an identity. It's an explanatory identity between the unfolded cause-effect structure. So it's an identity between powers and phenomenology. So
it's interesting because first you deflate phenomenology to something which is more formal and already not, let's say, you already remove some substance, let's say, from phenomenological experience. And then the thing that is identified is also, let's say, more abstract than brute brain.
This is interesting.
Stuff, right? So,
like like the phenomenological realm is reduced to a formal thing, and the abstract brain pattern, it gets kind of lifted to a more abstract pattern as well. Like they move in different, I mean, logically in opposite directions in a sense, right?
Yeah, because I mean, the axiom seems to extract an organizational consistency from general phenomenology, right? We don't remain, the axioms, they kind of extract from phenomenological experience this sort of basic intra-consistency, which is basically the organization of it. Doesn't say much about the content of that experience, right? It's very kind of almost a pure idea of organization. And then the approach to the physical substrate is also organizational. It's a matter of complexity, connectivity, integration. So you first adopt a perspective where these two things no longer are actually qualitatively separate realms. So it's hard. I wouldn't really call it a dualism, because what usually qualifies a dualism, which is a very profoundly distinct qualitative things, right? Physical stuff and this sort of immaterial experience, they're already transformed before you arrive at the identity. Like, you don't get the feeling like you've bridged such a big gap, because you can actually, it's an identity in the sense of saying such an experience is indistinguishable. I mean, it has the properties which this physical system also has. It's not saying something with property X is correlated with something with property Y. It's saying something with property X correlates with something with property X.
Yeah. So, I mean, it's interesting. So there are like two, so Julio actually writes that there are two approaches to think about like postulates. There's like a phenomenological approach, which asks what it takes for a physical system to be conscious. So given the axioms, given these like abstract general properties of experience, what kind of physical properties a system would have to have in order to like reobtain these same properties, and then get back consciousness. Another way is to think like, okay, what does it take for something like just like purely ontological approach, in which what does it take for something to exist as an intrinsic thing without regard to consciousness? So he will also argue that for something to exist intrinsically, you need something to be like, in this ontology of powers, of course, you need something to be like irreducible, specific, structured, intrinsic. So it's not an identity between heterogeneous things. You end up in the same like space in which like stuff like subjectively appear because cause effect power constrain itself in an irreducible way in which there's nothing else to do but to appear to itself. Like these causal constraints are so consistent and irreducible and maximal that you get subjective appearance. That's basically like that. So yeah.
Can we just revisiting the exclusion postulate again? Yeah. It seems to me like in that previous picture where we have the different complexes, this one, yeah, exactly. Yes. So are we saying here that using this phi, right? Or is it omega? I don't know. Yeah. Using this big phi, we're creating an order relation amongst partitions of these of our system, right? Whether it's a brain or anything else, but
no, I mean you extract no overlapping set. Like you cannot get overlaps, so you just get like mutually exclusive sets of local maximas of integrated information. So that's why you kind of end up in panpsychism, but it's a panpsychism in which you don't have like an unrestricted composition of like experience and there's like consciousness all over. It's just that because of exclusion, you're obliged to like exclude overlapping entities and only like the sets that are like maximally integrated exist. So only like non-overlapping sets. So you start to fill out all space, but you might do that at different scales, right? So maybe
it reminds me a lot of Badiou's kind of top and bottom idea of unity in worlds, because with the transcendental, you get this idea of some sort of maximal unity, maximal consistency of a world. But he says that he tries to derive from it the necessity that at the bottom level, something counts as one. Like you can have multiple things composing an atom, but ultimately you can only have one as the maximally counting atom, even if it has other components that participate in it, right? So the exclusion principle seems to kind of account for that idea that at some point you need a sort of cut or a certain bound, even if it's still connected to other stuff. Locally, what is maximally kind of interacting will count as the sort of the boundary of it, right?
Yeah.
But I'm just wondering I'm confused as to, so is the complex the atom here?
No. So the complex would be the system, and within a complex you have a cause-effect structure. So yeah, I'll get to so.
Oh, okay.
Yeah. So maybe we can discuss the principle of exclusion, like the rationale. But yeah, so just like so we can clear out on the identity here. So you have a physical system. We started with a physical system, and then what we're postulating is not an identity between this physical system, the substrate, and experience, because they are not similar at all. Like, but what we're doing is unfolding its cause-effect power and like looking for its irreducible parts, which is the distinctions, these maximally irreducible parts, which are like the atoms that constitute this whole, this like integrated whole. And then you also have like relations inside, and then you affirm this isomorphism between the phenomenal distinctions and relations you find in experience and the causal distinctions and relations you find once you unfold the powers of a system in a state. So the complex is maximally irreducible cause-effect structure, which is composed of causal distinctions, which are its parts, and relations, and each of that has like a small phi value associated to it, which could maybe interpret in terms of like the intensity of a certain like phenomenal distinction to appear. So the identity, which is it's written as an explanatory identity. So it's more that this cause-effect structure can explain and make intelligible experience again. So you shouldn't find like gap, like everything that appears, phenomenology, all its like phenomenal distinctions and relations and the way things are binded, you should recover that by unfolding the cause-effect structure of a system.
It is kind of, I mean, for Badiou addicted people, it's like the physical system is the actual ontological substrate. The cause-effect structure is like the transcendental on it.
Yeah, I was trying to.
You already have the
You already had
the Badiou cocaine.
Yeah, I figured. So does that make sense?
Yeah, that's where I was heading. Yeah, sorry, just can see the bottom one. Yeah, that's what I thought, like something like that. Because
now it makes more sense. Yeah,
it's pretty clear.
It's the fact that the complex can be broken down into
it's completely
subcomplexes.
overlapping, man.
Sorry, Dennis, you were saying something? The fact
it makes a lot more sense now. So the complex actually describes the way in which we can glue these subcomplexes together in such a way that we engender the maximum informational content, right? Or the SPI.
Yeah.
So the really genius kind of step in all of this is to give precedence to the cause-effect structure. I mean, you can see that there is a very interesting circularity, because if you didn't start with the axioms, you wouldn't select the cause-effect structure as the privileged kind of site of analysis, right? You wouldn't distinguish these physical substrates based on the causal effect structure. So you can see that the axioms, they make a very informed selection of what sort of systems are candidates for this. But then I mean, the fact that the cause, I mean, having the means to treat the cause effect structure as this sort of organized system of mechanisms, right? And to have the means to evaluate the sort of properties of it. That's really where it seems to be the thing that makes, I mean, brings the physicalist analysis of the brain up a notch in terms of, let's say it's not abstract in any kind of vague sense, right? It's not immaterial, but it's concrete, but at the same time it's more abstract, right? It brings it closer to phenomenology at the same time that your axioms already deflated experience enough to keep only the organization. So it really makes for a very different sort of connection between the two. It's really amazing.
And yeah, so the exclusion is really tricky because it works at two levels. So again, integration and exclusion, it's done as at the mechanism are the parts. So it is done at the system level and at the parts level. That's what's kind of tricky. So you want to see what, so given a bounded system, like you trace like a boundary in the, you get like an open system, you trace a boundary and you say, does that exist? So first you start to look what counts as one within the system. So I think there's like this move, you like enclose a global space, like a general space. And then you kind of start to measure what counts as one within the system, what are parts, irreducible parts of the system. And then you have to do something that's a little bit, it feels extrinsic because you're considering overlapping holes that could also exist like outside of the system, right? So there's an exclusion that works within, just like looking for what counts inside the system. And then there's an exclusion that works from the outside. Like it looks at if there are like maybe some bigger system that is more like irreducible and then excludes you out of existence. So one thing is like the one of the whole and the other thing is like the irreducibility of the parts. So yeah, so that's kind of like difficult to argue why you need this system level exclusion. But the idea is that you could imagine that you could have like infinite amounts of experiences, like faster experiences and like slower experiences and like fine-grained experiences of like the cells, like being integrating some like the neurons, like you could imagine like all sorts of like so say you have like a physical substrate of consciousness, like the posterior hot zone. You could imagine that there's an a conscious experience that's associated with that posterior hot zone minus one neuron. You should have like an experience that loses something but still exists. So you should have like all subsets of your experience should have like a reduced physical substrate, and then you could also like augment it with like more stuff. Then maybe have like slower experiences that integrate information on different scales. Then suddenly you would be like multiplying like experiences, and there's like some like parsimony like principle, right? So
let me ask you something that is individual concern of mine. What if you suggest a kind of experience that has certain parameters that has to do, for instance, with temporal scaling that is not integratable in the same sense for a human brain?
I don't know if I understood.
For instance, I have Gabriel knows this quite well. We worked like, I gave a class in his course like 2 years ago about this paper I wrote that was about certain, I'm a musician as well. So a certain pieces that I did that has to do with time stretching. So time stretching is this, digital procedure whereby you can change the let's say the durations of sound without changing the pitch. like in normal analog systems, you would have to change the pitch in order to change the duration, not in digital time stretching. So these pieces were basically changing like a certain structure, like you have a certain sound structure, like a piece. The piece has parts, has, you know, things that you might identify as antecedents, consequence, like different parts that relate in a certain way, right? Like when you listen to music, you are always supposedly doing this kind of logical operations in order to follow it like a discourse of sorts, like something like this. At least this is how we, in, you know, in musical analysis, try to treat the kind of cognition one may have when one is structurally listening. So in this paper, I was making a difference between structural listening, which is this kind of listening that is making the necessary logical relationships at the proper scale, from ambient listening. Ambient listening, my argument, which was very, very, let us say, how should I say, very intuitive, not scientific at all, was that, for instance, when I take a piece like that lasts for 5 minutes and turn it into a piece that lasts for 8 hours, all the structures are multiplied proportionally. You lose actually the scale wherein you are able to make the differences between phrases and parts, right? Because it is in a different scale. So how does the individual react? Usually, structural listening is sacrificed, and he lapses back into ambient listening. Sound becomes like an ambient thing. Actually, he is individualizing things, events within a different scale that is not the scale that he's supposed to be following. Like, the idea is how you preserve structure within a different scale, a different perceptual scale for the same human brain that was following it in the, you know, lesser scale, something like that.
Yeah. No, it makes a lot of sense. I mean, you have something like this concept of specials present, right? It's from like,
I use this concept exactly. Yes.
So you can actually like empirically measure that. So you can like put like 2 sounds, and then you just like you do like 2 sounds, and there's a range of intervals for which you perceive them as 2 sounds, like in the same like moment, right?
You're like the difference between a certain timbre that is kind of a roll, and when we start to individualize like two different sounds instead of like this grainy texture, like there's several sounds in it that are too close to each other, right? So you don't get to individualize them properly. So you have like I suppose you have a certain distance that you must have in order to individualize them.
You have like 2 critical points. You have like what's called like fusion time, is the interval at which you perceive 2 as 1, in which like the difference disappears and like stops to make a difference and appear. And you have like a difference that if it's like a bigger interval at which you start to, these 2 like sounds, they stop to appear as within a perceptual moment, but starts to become like the second becomes like a memory of itself. So I mean, it's like the difference between like, you know, Husserlian like phenomenology between like retention and memory, right? So it becomes like more cognitive, even though you preserved the same. So you had a certain, if I understood right, you had like a certain structure within perceptual time that you kind of like remap into like this broader, more like cognitive.
But this remapping, I find it kind of, there's something to, you know, the Kantian sublime going on in a sense. Like you have to appeal to the concept in a sense, because you don't have the actual experience of the same structure at the different time scale. So you have to appeal to the concept. You have to know what the structure is and start to actively identify the salient points wherein you could recognize within this different scale, the things that was kind of that you had an illusion of immediacy in the normal scale, something like that, right?
Yeah, you could think like primary like auditory cortices. They are optimized to like integrate to like they probably have like some sort of like network in the auditory cortex which is like optimized to like pick out differences at a certain like optimal range of intervals at which you would probably like integrate information and have like distinctions that map these perceptually like distinct sounds. But these mechanisms doesn't like they cannot do this. They don't work anymore. They don't like integrate information at longer scales. So then you would have to appeal to a different substrate, a different like cognitive.
Yeah. So yeah, you're confirming my hypothesis. Thank you. Yes. Yes.
Oh.
Should we end here because I know Karan has to go.
Yeah, maybe I have to go as well.
Would you guys be okay with doing? I mean, Causal, would you be okay with doing like part 2 next week?
Yeah, sure.
This way we don't need to like rush through stuff, and we can. I mean, now that you said all of this, I think I could reread the text, and I couldn't actually understand much more of it.
Yeah, me too. This was really helpful.
Yeah. I had some questions about the issue of panpsychism as well, but we can leave it to next week.
I copied on the chat here.
I saw the Chalmers thing, right?
Yeah, I really like the way that the questions that he asks and the things that bother him. They're
look into it.
They're very telling of his.
Interests me a lot.
Yeah, his approach to stuff. But yeah, basically we get to the central identity now, right? We just finished the exclusion principle anyway.
Yeah.
Yeah, and there's a lot of stuff. Huh?
Yeah, I mean, I'd be up for if it works for you, Renzo. I think that it would be profitable if we divide it in two, just so we don't need to rush through stuff, because there was a lot of stuff I wanted to ask, but I think it's better to have time, you know.
Yeah, for me it's good. Yeah, it's fine.
Yeah, great. Okay, so yeah. I'll upload this as part 1.
Yeah, the more to go through like the formalism, the main point is like understanding the intuition behind what a cause repertoire is, and then building one's way until like what the distinction is.
Yeah, I also had some question about induction, like you are assigning certain causal powers. It seems that has some inductive procedure going on, but then you mentioned inference to the best explanation, right? Which is an abductive reasoning, actually. So I wanted to ask something about this, but we can leave it to next week as well.
Yeah, this was amazing. It was really really illuminating.
And also, I think Howell's text makes a lot more sense now, because the way you presented, I mean, going through how, you know, probability theory actually kind of is the building block of everything here. It makes the whole, I mean, the transition probability matrix, I mean, just hovering over that in his text made for a not very good coarse grain.
I mean, if there's a really good slide, like presentation that was prepared by the guy who actually like coded the the software that is used to calculate all this stuff for like really small networks. It's called PyPhi, and he did like this really like algorithmic presentation with like 300 slides in which you can just like follow what's happening with the TPM. I mean, for some people it's really useful.
I like that. Do you have that?
Yeah, I'll look for it and send you.
Great.
Because yeah, I mean the article, it doesn't help, like the form, like the.
Yeah, Pedro is already sending it. Is this it?
Like, how can I see the chat? Ah.
Yeah, this is 227 page slide. I think
Yeah.
he beat both of us, Renzo.
But yeah, but it's.
Okay, guys, I have to get going. Tomorrow I'm presenting the theory of points in the Badiou group, so
yeah.
we'll see you there. I think I might integrate some of that musical scholium stuff that I presented in the Portuguese class. So,
Hey, if you can, JP, if you can send me this paper you mentioned.
sorry? Oh, the paper. Yes, of course. I'll do it. I'll do it right now. Let me just grab it here very quick. My Dropbox. Transcendental aesthetics of time stretching, like very
Because
fancy.
as a matter of fact, I might be starting to work on like a time project, an IIT time project. So that might be actually.
There you go. This is actually the facsimile of yes, the book. This is the book, the first page of the book wherein it was published. If you have any difficulty reading that, I can send you just a doc paper, like a PDF, with
Okay.
Which was my own, my own formatting.
Yeah.
I just took a facsimile of this, just for to get a scholarship, things like that, so people would see that it is published, all that. So this was why I did that. But sometimes the PDF is better for reading, so maybe I grab this here. Okay, I have a doc. I'll send the doc as well if you have any difficulty. No, not that one. Compartilhar. Okay. The doc one is here.
So was this the Bible for?
Yeah, it's this. Yeah.
Yeah. Okay.
I mean, it's like, look at this. It's like, it's almost like an animation done with slides. It's
Wow.
a lot of work, and it's like all steps you need to just like compute cause effect structure of this really silly tree node network. So
That's
there's
really
also, this is also nice. Which is also done by Will, which is like the guy who coded all the software. So you can like.
No way, that's so cool.
Then you like search for like a main complex.
Oh, amazing.
You have like a space of distinctions and then like it used to be called concepts, the distinctions, but that like got like lots of philosophers like mad, like, why are you calling it a concept? Like, it's not a concept. And so they changed to like distinctions, which I think is more like intuitive. But yeah, so the distinctions are all here and like that. And you can play with it. Yeah.
It's amazing.
And then there's a cooler thing, maybe I can also show next time, which is like animats, which is something like I worked a bit when I was in medicine, which is like these little animals in which like they evolve to solve like a problem. And then you calculate integrating information, and you see that integrating information is like an effective way to actually like use your nodes and your finite number of like nodes and elements to solve a task. So that provides like an evolutionary explanation for why consciousness appeared.
So consciousness is actually preferable in terms of let's say, an economy of distinctions then.
Yeah, it's like if you have like a fixed amount of like wiring and like activation that you can do, like you could always solve something feed forwardly, right?
Mm-hmm.
But she, like Larissa, which she shows that once you evolve them, they naturally like evolve in integrated recurrent ways, so as to like have like higher order mechanisms that can do like more stuff at the same time. So there's also like a, so you can evolve these things in like situated, like embodied, like more like natural, like environments in which like it makes sense, but you still have this very strong dissociation between like the intrinsic cause effect structure and the extrinsic relations that a certain thing can have with its environment.
That's amazing.
Yeah.
Yeah, I really recommend if any of you didn't see the lecture that he posted also from Juan, Andrew Juan, right?
Yeah, Andrew Hahn.
Han, yeah, man, it's so good. It really, I think the whole thing with spatial experience really gives a sort of concrete sense in which you're not really making a connection between two highly qualitatively heterogeneous realms. You know, when you talk about the central identity, it's really incredible.
Yeah. Yeah, and I think, yeah, that discussion point on like the colors and space, I think it's like the crux of like IIT being able to explain, to account for like the contents of experience. Because I mean, for me, like colors and pain is like the hardest, like because you get no structure, right? So you have to have explanation on why does it appear simple.
Yes.
And in IIT, everything is structured, so you have to have like a.
Yeah, I wonder. I mean, I'm not sure if I'm reading the exclusion axiom. I'm reading too much into it because it seems that on one hand the hardest one to justify, but on the second hand it seems also to be the richest one. Weirdly,
Yeah.
Like, and it seems to be the one that defines also. Let's say if structure appears as structure, or if structure appears as simpleness, right? Because it concerns a certain bound, like a certain boundary, weirdly. Like the way that we were talking earlier about color seeming simple, even though it's structured. It's not to say it's not structured, but it's almost like subatomic to what actually is the atom for that spatial structure, right?
Yeah, but I'm not sure if it's exclusion that it's maybe it is. I mean, because the argument that like they give in the spatial paper is that we don't have like the power to introspect. Like if you were able to like actually like change the gain inside like the neurons that code like color,
Yeah.
you would actually see the structure. Like you suddenly like unfold like something that looks simple, you would actually like get structure.
Mm-hmm.
But
yeah, but for me, that's, I mean, I'm first of all, it's hard because when you have axioms like this, also things that follow from the combination of them, it's hard to just pinpoint it back to one principle. And it seems like having exclusion and integration and composition, only if you think of all those things together, you get that idea that something can be, let's say, it can appear as unstructured within the intrinsic space of a given structure, right? That implies all the axioms in a certain way. It implies that it's bounded,
yeah,
and that mechanisms are exclusionary in a certain sense, and systems are exclusionary. But it also implies that this is the case for a certain integrated space, and it's not in general, right? So it seems to imply multiple axioms, but the result seems to be very much connected with this I mean, the way Andrew Hahn talked about it, he says, we can imagine this sci-fi scenario where I can simply, let's say, do something that increases the sort of intensity of that structure. And suddenly this thing that looks like one simple thing, you would kind of have a feel for its connectedness, right? In its own structure. But I wonder if that doesn't imply that things are kind of coarse-grained or simplified or kind of collapsed into the sort of simple experience merely due to, you know, like as if intensity of appearance is reducible to a sort of almost like a game, you know, like a quantitative aspect, and not due to, let's say, the structure between structures. Like it's more architectural aspect.
I mean, you have to find, I mean, so you have something that's color, which is like simple in itself, but you know for a fact that you have color space, right? You have like all like, have you seen like, there's a really nice, well, I'll send it later, but I mean, it's really complicated. Yeah, this. So, I mean, the fact when you see blue, you only see blue because there is the non-green and the non-red aspect to it. There's like this, at some point, like IIT used to define like negative concepts, like the absence of something that, like, for example, inactive nodes that specify distinctions, but they specify the lack of something. Right? So, so there's this whole structure that doesn't appear. So you should have, you have to find a reason for which you have structure, which is determining something from within and doesn't self-appear, right? So it's...
Yeah, I don't know. I mean, very intuitively, I think that the way that we discuss localization in Badiou, like this sort of, because it's so vague and undetermined, like underdetermined in a certain sense, it kind of implies this sort of view where you get something that is, let's say, this transcendental structure is maximally differentiating only so far as it cut off certain differences. Like if you were to include certain differential structures into it, you would lose capacity to glue back together the space, right? So for example, other examples, like if you have a painting where color is at stake, obviously, but figures are also at stake, the right resolution of that system to be able to kind of glue back together parts of it into the whole scenario is actually taking the figures as the atoms and the colors as localized on the figure. Like you don't say that arm is brushing on the red, you say the red is contained in the arm, right? So you localize the red on the arm, not vice versa. But that's not given locally, that's given by the relation between the parts and the capacity to syntactically glue them together. So there is a correlation between what allows you to, let's say, to maintain the cohesiveness of this transcendental space and a sort of trade-off at the atomic level of what localizes what, right? So for example, some colors will be relevant as a sort of simple experience because they differentiate, let's say, the sea from the land. But the inner differentiations of color are actually secondary, like they're localized on those main blobs or blue or green, right? So you kind of, though it's there, you you cannot keep both. You cannot have the means to describe the transcendental structure of the world, of the painting by the sea, and talk about the world of color. Like something needs to be lost for you to gain that cohesiveness.
Yeah,
So,
it's like the Goodman question. What do I have in front of me? A man or a swarm of atoms?
yeah, something like that. I mean,
Something like that.
yeah, the atoms are localized on the man if we're talking about a sort
like
of...
within my, I mean, normal manifest ontology system of coherence. Well, I have a person in front of me. This is
Yeah,
one
so
unit.
yeah, so I like the way that the atomic logic works for Badiou, because it seems to me that it connects with a lot of aspects of the exclusion axiom. Like, you need to have a sort of lower bound of what counts as one based on its coherence with the principles of differentiation in that system, like it being integrated in the transcendental, which doesn't mean that what's below the atom in sense of like even finer detail is not there. It might be there, but it will be there with a sort of simple existence, perhaps, right? I think an example that Badiou gives that is good, that has nothing to do with consciousness is, for example, in a factory, the worker is there with a bunch of particular predicates, but for, let's say, the intrinsic existence of a factory, he's only labor force. That doesn't mean that all the other properties are not there, but they are kind of simple in the sense that you cannot treat them as structured. Like you can, for example, Reza gave a really good example last meeting or 2 meetings ago. Like, for example, imagine in a factory where suddenly all the workers stop to pray because they're Muslims. Like, the fact that they're Muslims is a structure. Like, it has a structure. For example, the time of prayer. But from the intrinsic existence of a factory, that's unstructured. Like, it's just an attribute of the worker that has absolutely no differential capacity. It doesn't cause anything. So if you ask,
it's noise, right?
It's noise, exactly. It's like, but from the standpoint of the workers, it might have causal capacity. So if, let's say, if they go on strike so they can pray, so if they impose the time of prayer on the time of work, it's proof that there was structure where it just appeared as a simple appearance from the standpoint of the factory, right? So it's just that sort of analysis where you're not saying that things that don't have high degree of existence or they're not they don't have enough causal power in that world, they might be structured, but they might be, let's say, cut off because of a trade-off between the transcendental structure of that world, meaning its way of integrating and gluing its own parts, right? So it's a way of approaching this sort of thing that seems very close to me with the way that composition, integration, and exclusion kind of get combined, right? That you still need to, not only do you need to make an analysis of composition of these little systems and their integration, but also you need to kind of find out at what resolution they are maximally, you have maximal effective information, right? And at that level, some things might become, let's say, unstructured for that space, which doesn't mean that they don't have structure, right? It might just not appear. So like the way that Andrew talked about color, it really kind of resonated with that kind of.
Yeah, I agree.
He says, well, I imagine that this node is internally structured. It's just not internally structured like a grid. The internal structure is something else, right? It still is tied up with another kind of weird network, but you cannot get spatial coherence if that inner structure counts. Exactly, right? Let's say if this inner structure, which is not grid-like, right, were to count, you would lose the complex grid coherence of space. So it's almost like a trade-off of what needs to be in the background so that something can be integrated, right? Like what kind of gains the quality of not existing, right? In a certain sense. So I don't know. I don't know. I see a lot of stuff that's very, very very relatable. Let's put it like this. And it's crazy, man. I don't know if all of this is just really incredible.
Yeah, I think it's, yeah.
Sent you another thing I wrote. Wanted to see what you think of it, Renzo. It's in the chat. Just to say that. I have to go now. Sorry. So.
Yeah, same here. I gotta go.
Okay, guys. So we can pick up next week then. Renzo, thank you so much, man. This was
thank
so
you.
amazing.
Thank you.
Okay, I'll upload the
Just a question. Is there like a website or something for this group, like the Badiou?
No, we didn't create anything.
Like it would be nice to have a place to, you know, have the chat bars perhaps, and maybe notes. I don't know. Just a thought.
Yeah, we can. I mean, we're already kind of struggling with the Badiou one. I didn't want to, right? But yeah, at some point, I think something like that. It would be useful to get other people involved. Also, one thing I'm gonna just ask in the chat. We spoke about this a long time ago, but I thought we could kind of come up with a calendar to invite people to join and like present something. Like I think we already
you told me this. I was with Patricia Reed last week. She was up for it, but she's kind of busy in September. Perhaps she could present something in October. She just published a text like that has to do with scales with this guy Anil Bawakavia, who's an artist and computer scientist, and maybe she could present his text to us. I don't know. So this was the idea. Gabriel suggested me to invite her. So she was interested, but not for now, immediately.
Yeah, but I mean, I think we could come up with a list. And I mean, that would be a justification for in the near future trying to have a kind of a public face, just so we can tell people, look at this, you know.
Yeah.
And we could come up with a list of people we could try to invite from time to time as well, just so we can get like a first-hand account of stuff that might be interesting. Raquel also suggested this really good philosopher and economist from São Paulo called Jorge Grespin, who studies the transformation problem in a very novel way. So we thought of inviting him. He's translating his book into English, so he probably would be interested in it anyway. So I don't know, just if you guys want to think about possible people, we could also think about that as well.
Okay, guys. Thank you. Thank you, Renzo.
See you next week.
See you tomorrow, I think.
Actually, see everyone tomorrow, but anyway.
Yeah, perhaps, I think everybody will be there. So yeah.
See ya.
Bye.
Bye.
Take care. Bye.